Hello students, welcome again. In this video we are going to talk about different types of pins that we have on Arduino Uno R3. We had briefly discussed in the previous video that we have the support of analog and digital pins, but they are not the alone. We have a lot more. So we have digital pins and analog pins. These are the ones which we already know. In addition to that, we have the pins for pulse width modulation. We have power pins, serial communication pins, SPI I2C communication pin, and pins which can work for interrupt signals. So now let us have a closer look at all of them one by one. So the first category that we have is power pins. Power pins are on the left side of the board, and these are used to power something which is outside the board, some external components, sensors, all of them. So these can be powered. We can supply ground, 3.3 volt and 5 volt using these pins. These pins definitely have some limitation in terms of maximum current that can be provided. So the maximum current is few milliampere, so they are good to glow an LED, to control an LCD, but not good for running DC motors or anything which require high current. Then we have digital pins. They are on the right side of the board. They are numbered 0 to 13. So D0 to D13, these are the 14 digital pins. Some of them are used for some other kind of communication also, but primarily they remains as digital input output pins. So there are 14 such pins. A digital pin will have two states, low or high. That means their inputs as well as output will be either 0 or 1. They can be read and they can write the data using the commands digital read or digital write. When we go through the programming concepts, we will discuss about these commands in detail. So next we have PWM. PWM stands for pulse width modulation. Now we had told that we don't have analog output pins, but if I want to generate something which is not purely 1 or purely 0, then the alternative that we have in the digital world is pulse width modulation. So pulse width modulation means we are going to control the duty cycle of our output digital wave. If I say I have 0% duty cycle, that means my output wave is never high, or it is high only for a very small amount of time. That means effectively we will not be passing any power through that output waveform. If I say the duty cycle is 100%, that means we are giving maximum possible power through that signal. Then we can change the duty cycle to decide that on an average how much power the signal is carrying. So based on the duty cycle, we can decide that how much average power we want to transmit. Next category that we have is interrupt pins. These are two pins in the digital side, pin number 2 and 3, D2 and D3. These two pins can be used as interrupt pins. A specific function which need to trigger the ongoing operation can be connected on these pins. These signals will always have the higher priority. That means any operation which is going on, if the interrupt is detected, that particular operation will be stopped and the function which is related to the interrupt signal will be taken care. Next we have serial UART communication. These pins are pin number D0 and D1. They come in a pair and they will have a transmitter as well as receiver. When we are having serial communication, we can attach components like Bluetooth module or serial monitor, and this will give us a very good feature for interacting with other devices. There is only one pair which is available on Arduino Uno, and one pair contains 2 pins. Next that we have is I2C pins. I2C, there are 2 pins. They are on top of the board above digital pins. Each component have their own ID when they are connected through I2C. So these components will act like a master and slave. So one component is going to control the operation of the other component. Some of these components that are compatible with I2C protocol are MPL 3115A2 temperature sensor, MPU 6050 gyroscope and accelerometer sensors, TCS 34725 color sensors. So as you can see, these are the sensors that we can attach through I2C protocol, and we can control them using our Arduino board. So they will act like slave and Arduino will act like the master. A similar protocol is SPI. In SPI we have 4 pins from D10 to D13. It is also a master-slave architecture. Here we can connect another Arduino board to our existing Arduino board. Of course, we can attach another component also which support SPI communication. So this is also a master-slave configuration. Some of the components apart from Arduino which support SPI are AS5047D magnetic position sensor and MAX31855 thermocouple. So this is how we can connect one Arduino board with another Arduino board. One of them will be master, the other one will be slave. So now when we know about different pins and a good idea about the hardware, let us go to the software part. In the next video, we are going to talk about how to install the IDE for Arduino. Thank you.